And we already used it. Let that sink in. Let that sink in.
All right, so we're ready, I'm on page 41, letter G, here we go.
I'm ready to learn.
Ready to learn. So I'm just gonna draw this the best I can. Okay, so I got a ship right here, and I got a ship right here. And this angle is 42 degrees, 30 minutes. And the whole big angle is 52.12. And these guys, they've gone 25 miles. So the radius of the circle, if you think of this as a big circle, the radius is 25. Would you agree with that? Okay, so here's the deal. We want to know how far apart they are. Now, they drew a nice picture for you. So can you see that the distance they are apart is actually an arc? And how do we deal with arc length? What's our little formula? Arc length equals radius times radians. And my radius is 25. Now, the angle I'm looking for, this angle right here, is going to be this one. Would everybody agree with that? And that angle is going to be 52.12 minus 42.30. Would everyone agree with that? Okay, so I'm going to subtract. But here's the problem. When I go to subtract, 30 is bigger than 12. So I'm going to have to borrow a degree. So I'm going to make this a 51. A degree is how many minutes? 60. So this is going to become a 72. Did everybody follow that? In order to subtract my minutes, I had to borrow 60.
What's your calculator do that for you?
I don't know, let's try it. It might, actually, now that you mention it, it might. So if I type in, okay, so you go ahead and do it on the calculator. I'll finish this and we'll see if we get the same answer. 9 degrees, 42 minutes, see if that's what it gives you. So you would just type in 52.12, remember we learned how to do that yesterday? And then minus 42.30.
8.7.
Yeah, 9.7.
Okay, DMS that.
Oh, I typed in there.
Yeah, if you got 9.7, that sounds about right. DMS that, and does it come out to 942? Okay, so you can do that on your calculator. You're gonna have a calculator to do this problem, you can do that on your calculator.
How do you do this?
You just go DMS the app.
I know, you put it at the end of the equation.
Yeah, you just put the number, press DMS, and then press it.
Okay, so the angle is 9 degrees, 42 minutes. Or, before that, it was 9.7 degrees, right? Is that what you said, 9.7? Now, what's the matter? I still have work to do, because in order to find arc length, don't I need that to be a radian measure? So, pi is 180, I know that. I want to know what's 9.7? So 180x equals 9.7 pi. So what is my radian measure? 9.7 pi divided by 180. And now I can type that in on my calculator. 25 times 9.7 pi, use your pi button, divided by 180. I think these ships are about 4.23, is it miles? Miles.
So wait. This.
Let's do the 25 right here.
No, 25 is radius.
Yeah.
Oh,
That's how far they've gone. So these are all 25.
Oh. Oh, because that's the radius out. Oh.
Yeah,
Okay.
the ships have sailed 25.
Okay.
bigger,
Huh?
even though it looks bigger, like on the sides, it's still 25.
Yeah, yeah.
It's not just yellow.
It's a circle, and they're all 25.
And then what do we do? Because that was.
And
Is that the radius? Oh, that's the radius.
So if you, when you do it, yeah, it's not fine.
Okay?
The part that's blue.
The radius.
All right, letter H. We got some tires. And we're not gonna find the speed of each vehicle, we don't have time to do that. So do you wanna do the Taurus, the Charger, or the Mariner? The Charger, all right, here we go. So we're doing this for the Dodge Charger.
Track on.
Okay, find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. Okay? I think we did these earlier this year. Could be getting that confused in my brain. But we want to know miles per hour, and we are starting with revolutions per minute. So we're gonna start with 800 revolutions in 1 minute. Everybody good with that? That's what we know. That's what we start with what you know. And then we're gonna do some stoichiometry until we end up with miles per hour. That's where we're headed. Now, the key to this is, what is a revolution? One time around. And one time around is called the circumference. Right? So every time the wheel goes around, it travels a distance that is its circumference. How do we find circumference? 2 pi r. What's my radius? Be careful. It's half of 28.63, which is 14.315. So one revolution, whoops, not equal. One revolution is a circumference, which is 2 pi times 14.315. And what's the unit on that? That wheel is inches? Yeah, I'm not gonna erase this. Everybody still with me here? Now, the revolutions have canceled, and I now have inches per minute. And my goal is miles per hour. So let's do the minutes first. What do we know? We know there are 60 minutes in 1 hour. So now my minutes are gone, and I have inches per hour. Okay, to keep it on the video, I'm gonna come down here, but pretend it's tacked on there. So now I've got inches and I need miles. So I know that 1 foot is 12 inches. So now I have feet per hour. And I know that 1 mile is 5,280 feet. So again, I know I'm gonna tack it up here so you can see it. But it'll be off the video. So look what we're left with after we did all that. The unit there's a lot here, but the unit that's left on top is miles, and the unit that's left on the bottom is hours, which is exactly what we wanted. All right, so let's see how fast we're going. So 800, I always do my whole numerator first, divide by the denominator, but you can type it in however you want. 800 times 2 pi times 14.315 times 60. Okay, now I got my numerator. So I need to divide that by 12, and then I need to divide it by 5,280.
Yep.
I think our car is moving 68.14
Yeah.
miles per hour. All right, we're gonna do problem I now. It is exactly the same time. Thank you, sweetheart. All right, so we're gonna do letter I. And why don't I shut up a moment? And let you guys see if you can get it started or finished even. Problem I. You're gonna be doing exactly what we just did. So start with what you know. What do we know? We know 44 feet per second, so that's what we're gonna start with. And where are we heading? Revolutions per minute. All right, so take a few minutes and see if you can do this. Does the order you do things matter? No, so don't sweat that. Just start making some changes.
60 minutes in an hour. No, we have
So we have to do something like seconds and a minute. Which one do you
That's really good. You need to know that.
Jimmy, what did you do first?
We first that we did was multiply it by 60 seconds and a minute.
So you said 60 seconds, 1 minute.
Yep.
So now he has feet per minute and he wants minutes, right? So we're good. Now we gotta get from feet to revolutions. Now what is the key? A revolution is a circumference. So we're gonna say 1 revolution is a circumference, which is 2 pi times the radius, which is, where's my paper? The radius is 13. Everybody okay with that? And that's inches. So, uh-oh. So I need to cancel feet and inches, so I'm gonna have to say 12 inches are 1 foot. So the feet will cancel, the inches will cancel, and the unit on top is revolutions, and the unit on the bottom is minutes. So we'll type it in and we'll find out. Remember, guys, everything in the bottom is getting divided by. So you're either gonna say divided by 2, divided by pi, divided by 13, or you're gonna put all that in parentheses and divide by that parentheses. Every number in the bottom is a divided by. So. Divided by. I got 387.85 revolutions per minute. Anybody else get that? Did you?
Oh, shoot.
It would be a shame to do all this and not get the right answer. Make sure you're typing it incorrectly. Make sure I'm typing it incorrectly. You good?
Yeah.
Yep.
Are those revolution things, are those always gonna be in inches?
No, that depends on the radius. Because your revolution is a circumference, 2 pi r. So if the radius is in feet, your circumference is gonna be in feet. Okay, we good? All right, now we're ready. Get your green sheets out.
It's like it's so risky.
Did you get that
Colin,
one?
where are we even?
Yeah, that's like last week.
I literally just stuffed it in my binder.
2 of 20, did you 20? I wasn't in here for the conference.
I messed up.
I don't know if I have
No, that's the table doesn't.
I didn't know if when you were playing the wall in there if it was the song, but it was something.
I
That was so
know.
weird. Yesterday I was dying after a rest. We were doing hills. We were doing hills. And Sydney comes up and she looks out her window.
Right, where's
And I
yours?
was like, this is perfect.
Roll my algebra.
No, I said just go.
Just look at this.
Just go.
All right,
This is smart. Harvey,
so here we go.
district smart for this, you care. Do you even care?
There are 6 trigonometric functions, and by trigonometric functions, we mean things like sine, and cosine, and tangent. Those are the big 3, those are on your calculator. And then we have their co-functions, or their, I shouldn't say that, their reciprocal functions, the secant, the cosecant, and the cotangent. So all of that is on your sheet, along with their definitions, okay? It's all right there for you. The one thing we have to make sure you are crystal clear on is which side is which in the triangle. So for problem 4.2, oh, by the way, homework 4.1 due on Thursday. All right, 4.1 is due on Thursday. If you lost, I just gave you a homework packet yesterday. You shouldn't have lost it already. Okay, so we got this right triangle. In chapter 4, we're gonna be dealing with right triangles. In chapter 5, we'll branch out. But this is a nice little right triangle. This side is always called the hypotenuse, always, across from the right angle. Right, Royce, you paying attention, sweet pea?
Yeah.
Okay. Now, the other 2 sides, the legs of the triangle, are referred to as opposite and adjacent. And that depends totally on which angle you're using in the problem. So, in this triangle, the angle we're using is right here, it's marked, right? That is your theta. So when we find the sine and the cosine, etc., for theta, we have to keep in mind that this side over here is the opposite side, and this side is the adjacent side. Now, did you learn that before?
Yes.
So that makes sense to you? Opposite means across from it. Adjacent means right next to it. But you don't know what's opposite and adjacent until you identify your angle. So there it is, opposite, adjacent. Okay, so now we're gonna fill these things in. If you've already memorized, then you're all set. If you haven't memorized, you have your reference sheet right there. Sine is opposite over hypotenuse. So sine will be 2 over root 13. Yeah, that's sine. Sine theta equals 2 over root 13. Aren't I on 4A? 4 point, oh my gosh, I'm on the wrong notes. I am so sorry,
Yeah, I
you
was
guys.
confused too.
Yes, I picked up the wrong set of notes. All right, let's back up. Let me use your notes. This is still 4.2A, but here's your triangle. Does this look more familiar? All right. I got too many people doing trigonometry. Okay, well, yours is a little harder than the last one because something's missing. So what are we gonna have to do? Pythagorean theorem. And remember the Pythagorean theorem, when you do it, this is the hypotenuse.
16 plus x.
So 2 squared plus, I'll call it x squared, equals 5 squared. Is that all right with everybody? So 4 plus x squared equals 25, so it looks like x is going to be the square root of 21. If you have 2 sides, you can always find a third one of a right triangle. Always, always, always. Now, this theta is in the same place as the other one was. So here's our opposite, here's our adjacent, and of course this is our hypotenuse. So now we're ready, now that I got the right problem, to do our functions. And we're doing all of them. Okay, so here we go. Sine is opposite over hypotenuse, so 2/5. Now I matched these up for you because we're just learning all this. The cosecant, this is your abbreviation for cosecant, is the reciprocal of the sine. So if you look at your definition of cosecant, doesn't it say hypotenuse over opposite? So as soon as you know the sine is 2/5, you automatically know the cosecant is 5/2. You need to memorize sine, cosecant, reciprocals. All right, what's the cosine? Let's look at our picture. Cosine is adjacent over hypotenuse, so root 21 over 5. Which means the secant, which is the reciprocal of cosine, is 5 over root 21. So sine, reciprocal is cosecant. Cosine, reciprocal is secant. The cos don't go together. Sine, cosecant, cosine, secant, okay? And then of course tan and cotan. So what's tangent?
Opposite.
Tangent is opposite over adjacent, so 2 over root 21. And then cotangent would be root 21 over.
What's the point of the cotangent?
You know?
Or what's the
What?
point of like the cotangent of the opposite?
Well, that's a great question. So Braden says, why do we even have these reciprocals? What do I need them for? There are 2 things. First of all, there are identities, which are formulas that involve those functions that we need for calculus, okay? The other reason is, and I think one of the primary reasons is, before calculators, all of this had to be done by hand. And if we had a problem that said, the tangent was, let's say, 0.813, which is the tangent value, we need that 0.813 is 5.42 over x. If we use the tangent, then this is what the problem would look like, and we would end up having to do this division. Now remember, no calculator. So you would be dividing 5.42 by 0.813. If we did it as a tangent, then it would be a different number, but the division would look like this. And it wouldn't be a division, it would be a multiplication. So I used, back when I was your age, I used cotangent a lot, and cosecant and all that, because I didn't have a calculator, and multiplying is easier than dividing when you have all those decimals. You guys are just the opposite. You're not gonna wanna use the, cotangent and secant, because you don't have those buttons on your calculator, so every problem you do is probably gonna be a tangent. But you need to know these reciprocals so that you can verify identities and do stuff like that later on. All right, first problem, everybody good? All right, let's try the second one. I think it's about the same. So go ahead and try B. Just like A, you're gonna have to find the missing side using the Pythagorean theorem. And then you're gonna have to figure out what's opposite, adjacent, and hypotenuse. And then you can start filling them in. Yeah. This was last year's 18 calculus exam. That problem right there. So that's tangents. I was
That's the final one.
No, this is 8 right here. Were you able to find the missing side?
Yeah.
Okay, what did you come up with for the missing side? Square root of 34. Perfect. And it is the hypotenuse. With regard to this angle, what was that? Someone's phone? I don't know. With regard to this angle, this is the opposite and this is the adjacent. Everybody agree? So sine is 3 over root 34, which means cosecant is root 34 over 3. On test day, I am not going to have these lined up for you. You need to memorize the reciprocal of the sine is the cosecant. All right, cosine is 5 over root 34. And tangent is root this. How does that look to everybody?
Good.
Trigonometry is so easy if you memorize the rules.
Which are the rules for those
Huh?
side rules?
What?
So,
It's on your green sheet. The definitions are all on your green sheet. And I heard Michael say SOHCAHTOA, which is a mnemonic device. Chief SOHCAHTOA, chief of the trigonometry tribe. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. So certainly use SOHCAHTOA if that helps you. All right, number 2, same thing, except they did not give you a triangle. Instead, they gave you the secant. So we are on problem 2A. So we know if the secant is 3/2, the cosine is 2/3. And Michael is saying, okay, they may not have given me a triangle, but I'm gonna go ahead and draw one in standard position. Yeah, they didn't label it though. And if the cosine is 2/3, then the hypotenuse is 3 and the adjacent is 2. Okay, what's the third side? Huh?
We have to do a squared, b squared.
Yep, have to do the Pythagorean theorem to find that third side. So what does that turn out to be? Square root of 5, very, very good. If you got root 13, shame on you. A squared plus b squared equals c squared, and c is the hypotenuse. So it's the square root of 5. Everybody okay with that? Square root of 5? Okay, yeah, I'll be able to fill the rest of it in then. So here we got opposite, here we got adjacent, here's our hypotenuse. What's the sign? Root 5 over 3. So the cosecant is 3 over root 5. What's our tangent?
Root 5.
Root 5 over 2. And cotangent is 2 over root 5. How do you feel about that?
Very good.
B, problem B, is exactly the same. Try it right now. Try B.
If they don't give you a triangle, can you just choose where the triangle is?
I would suggest you always use this triangle
Just that.
because our angles are in standard position that way. For this particular problem, I don't think you have to, but it's just gonna make our life easier if we get in the habit of drawing them this way.
Is the, what's that circle?
Theta,
Theta? Is that always goes on?
at the origin, standard position, at the origin. Can I have somebody come up and put your answers?
How do I know?
Up here
Is the opposite 5?
for problem B. Jimmy, what's your question?
How do I know which one is the opposite?
Okay, so your angle is right here. You're gonna put you have to identify an angle, so you're gonna, I would suggest always putting it at the origin,
Yeah.
okay? And the minute you've identified your angle, then the opposite's gonna be the one across from it.
But
These aren't the right numbers, these are from the last problem.
wait, I don't understand. Wait, can I go up and show you something?
What?
Can I go up and show you something?
Yep.
Like all this told me not to do this. But I originally drew my angle right there. And then he was like, just drop tradition. But if I switch my angle, it's getting different.
No, because if you switch your angle, then this becomes opposite side, this is opposite over facing. Tangent is opposite.
Oh, yeah.
So it's okay to draw that triangle. I'd like you to start getting the habit of putting it in positions.
Yeah, I've got it.
That's just
Alright, so is it, you guys
Yeah, I thought. Me and Royce said
You got the right answers? Alright, would everybody look up here and compare? Are we going to agree that Royce and Michael and Brayden got the right answers up here? Boys and girls, agree? Nod? Yeah? Good. Alright. Now, we're gonna do the real stuff now, okay? So, here is your job. You are going to find the exact value of the sine of pi over 3. Okay, now, I don't know if you've ever done this before on your calculator. Just take your calculator out and just for fun, press sine 10. SIN 10 equals. All right, what kind of number did you get there? You got a big old decimal, and if you had to write that down in the answer blank, you would have to round that off, right? Not exact. When you do something on your calculator in trigonometry, it will not be exact. So when it says find the exact sign, that means we have to do it by hand, okay? So we're finding the sine of pi over 3. Yesterday may have been the very first time in your life you ever looked at a radian measure of the angle. This is radian. We had done degrees. What is pi over 3? Let's do it in degrees. You remember?
180.
No. Pi is 180, so this is a third of that, so that would be, you remember from yesterday, pi radian, so if this is just pi, that would be 180. But it's divided by 3, so it will be 60? So we have a sine of 60. Okay, now, remember that triangle you drew a minute ago for that other problem? I want you to draw the same triangle. But, before we put a theta here, because we didn't know the angle, now we're going to put a 60 there. And it's a right triangle, so that's a 90, which means this guy up here is 30. You don't need to write that down, but I want you to recognize you have a 30, 60, 90 triangle. And they are special because every 30, 60, 90 triangle will have sides that are in exactly the same ratios. That is on your green sheet in case you have forgotten from geometry. In a 30, 60, 90 triangle, the short leg is 1, the hypotenuse is 2, and the long leg is √3. Would you agree with me? Now look at what you got here, folks. Your job is to find the sine. We know that sine is opposite over hypotenuse, right? Well, wait a second. If that's my angle, we're not doing 30, we're doing 60. That's our angle. So this is the opposite, and this is the hypotenuse. So what is the exact sine of 60 degrees? √3 divided by 2. These are the ratios in a 30, 60, 90 triangle. They're on your green sheet down at the bottom. You need to remember that. They never change. They never change, okay? In a 30, 60, 90, across from the 30 will be 1, the hypotenuse will be 2, and across from the 60 will be root 3, every time. Gosh, that's not bad, it's pretty cool. All right, let's find the secant of pi over 4. Okay, so how are we gonna start? We're gonna figure out how many degrees that is, because in your life, you have not memorized pi over 6, pi over 3, pi over 2 triangles. You memorize them in degrees, 30, 60, 90. So we're gonna change this into a degree. What is 180 divided by 4? 45. So we're finding the secant of 45. Now draw the same triangle, guys, in the same shape there. But this time, your angle at the origin is 45. Right? Now look on your green sheet. If you don't remember, look on the green sheet. What are the sides of a 45, 45, 90? 1, 1, root 2?
Yep.
You ready for the good news? Those are the two special right triangles, 30, 60, 90, 45, 45, 90. So you can memorize those, and that's it. Okay? Now, we want the secant. Here's where you gotta think. Secant, I'm remembering SOHCAHTOA. And secant is reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent. So that will be root 2 over 1 or just root 2.
Is it okay to think about it like you could just cosine and just flip it?
Oh, absolutely. He said I'd rather think about it as cosine, figure out what cosine is, and then turn it over. That's fine. Absolutely fine. Wow, is this cool or what? All right, you guys try C and D. Try C and D with each other.
Okay, so it's only
Why are you?
No, I'm
doing
not,
that?
I'm not. I just remember.
All right, I gotta go 7.
Is that yes or no?
Yeah, quickly. But I can't hang around.
No, you're
So first off, so
All right, we're doing C and D.
so then it is equals.
The short way goes across from 30. Always across from 30.
Wait, you're talking about
Adjacent over square root 3 over 2. Did you get square root 3 over 2? Wait, for C? I don't think so. Wait, where'd you put your 2 ones?
The two hypotenuse.
Yes.
One's the opposite.
Yeah, so one's like. Wait, oh, wait, wait, no, no, no.
Has anybody gotten an answer to the
One
first one?
There's one over root 3.
Okay, so the answer back there was 1 over root 3, okay? I don't know if that's right or not, we're gonna do it and see. Anybody else get that?
Yes.
Couple of you did, okay.
Now you know.
So, first of all, pi over 6 is 30 degrees. Would everybody agree with that? 180 divided by 6. So my 30, when I draw my angles, this is going to make your life so much easier if you just do it the way I do it. Set up a coordinate axis system, quadrant 1, right there goes the 30. okay? Or whatever your angle is, this time it's 30. Now, across from the 30 is always 1. We're not gonna discuss that, that's fact, that's how it is, you learned it in geometry. The hypotenuse is always 2, and the other leg is root 3. Now, tangent, if you think about SOHCA, TOA, tangent is opposite over adjacent. Your angle is always, hopefully you're drawing it, at the origin. So this is gonna be the opposite side, and this is gonna be the adjacent side. So 1 over root 3 is absolutely correct. 1 over root 3.
That's what I just did last one.
You good?
Yeah.
Now, this one is 60 degrees.
Yes.
So this time the 60 is at the origin. Now, is that triangle the same as this one? Yeah, it's a 30, 60, 90. But this time the 30's up here.
Yeah.
So this is the 1, and the 2, and the root 3. Right? Now, I want cosine. Cosine is adjacent over hypotenuse. So here's your angle. So this is the adjacent. So how many of you got 1/2 as your answer? Perfect.
Adjacent because
We're gonna spend a lot more time
like the original angle you have.
on this, but right now I want you to get your calculators out.
So like the 60s representing so like this is
Now, I want you to look, we're using our calculators, and I want you to look at these 6 problems. And I want you to notice that some of them are in degrees and some of them are in radians. Okay? Your calculator will handle both. You just have to make sure that your mode is correct. So here's what I'm gonna do. I'm going to identify all of the degree problems. So A is a degree problem, right? How do I know? It's got a degree mark. If it's got a degree mark, it's a degree. If it doesn't have a degree mark, it's not a degree. So A is a degree, B is a degree, and E is a degree. These are my degree problems. So I'm going to do those first. All the degrees. So now I'm going to go to my calculator and I'm going to press mode. And I'm going to make sure that degree is highlighted. See the row that has options, degrees, radians? I'm going to do the degree problems now. So I have to be in degrees. I'm in degrees. Go to mode, highlight degrees. Okay? Now, first problem says secant 10. You do not have a secant button. So you got to remember what secant is. What is secant? Reciprocal of cosine. So you're going to literally type 1 divided by cosine 10. Secant is the reciprocal of the cosine. So 1 over cosine. You should have gotten 1.0154.
Yes.
How do you do a secant on your calculator? 1 divided by cosine. Are you starting to see how much there is to memorize? There's a lot you gotta remember. It's easy, but you gotta remember it. All right, so that's the first one. All right, let's do B. Do I have a tangent button? Yes. So I'm just gonna type tangent. 28, how do I get the degrees? Second angle or second apse degrees. 11 second apse minutes. .5358?
Yes.
.5358? Where's your calculator?
Got it out.
Can you see the steam rolling out of my ears right now? We've gotta have a calculator. All right, now we have E. Problem E. No.
Oh,
E is a sign problem.
I was looking.
Do I have a sign button?
Yes.
Press it, sign. And then 129 degrees, 18 minutes, and 13, where do I get that seconds again?
Alpha
Alpha plus, super.
plus.
0.7738. Okay? All the, where's your calculator? All right? Now, all the degree problems are done, so guess what I'm gonna do now? I'm gonna go back to mode, and I'm gonna change my calculator into radians. Your calculator, you have to tell it, is this a degree or is this a radian? It doesn't know unless you tell it. So I'm telling my calculator now, I'm in radian mode. I want the cosecant, which is 1 over sine. So 1 divided by sine, 5 second
All
pi
right, Precal, as we head into
divided
one
by
period, let us
16.
pause. Be mindful of all of that.
1.2027.
A quick reminder before we head to the prayer, there's snacks in the chapel at 11:50 with Father Joey if you would like to join them. Now let us pray. In the name of the Father, Son, and Holy Spirit, amen. Lord, thank you for the food before us, the Irish family and friends beside us, and the love between us. In Jesus' name we pray. Bless the Lord and be thy guest, spirit on free feet, from the mountain and Christ our Lord. Amen. In the name of the Father, Son, and Holy Spirit.
All right, now you can go. We'll finish this up tomorrow. Please, let's bring our calculators. Let's be responsible.